In this section, we're going to discuss in general the idea of methods. Methods are an organizational structure of a program that allows a number of statements to be grouped and referred to by a name. We have certain mathematical concepts, for example, square root, that we use the term square root to provide an idea of what's going to happen without specifying exactly how it's computed. We often use calculators or other computers to do that. We don't precisely know how to compute it by hand. We don't need to because we're using the idea of a piece of code or a function written and hidden away but available for use. Most methods are used to compute a value, like the square root example. The method is therefore an expression. It has a type and it has a value. We often ask square root to compute the result of a specific number that we give it, but we never tell square root what that number is when we're writing the square root function itself. We say for any legitimate input value, here's the method or algorithm of how to compute a square root value. In our code, when we call it, we give it a specific value and it says, okay, for this value, this is the result. But it works for any input value. That generic approach is typical of how a method should work. It should work for any legitimate input value. We as programmers, when we write a method, don't know what that value is, so we have to write the code to implement an algorithm that works in general. Because a method is general and it's accessed by name, it can be used many different places in a program. Once written and available, it is able to be used wherever needed, which means if we have a repetitious computation, for example, square root used scattered throughout a program working with geometric figures, we only have to write it once, or technically, in our case, we would access it from a Java library, but it only has to exist once, and we can call it many, many times. Mathematics uses specific terminology to describe the transformation of data. Here's an example that's typical from algebra books. We see f of x equals x squared plus x, or anything on the right-hand side, some transformation. Not being quite mathematically adept, I always struggled with this as a kid. I didn't know what f meant. It's just a general term for a function. F is just a name of a transformation. And in general, as most mathematicians like to do, they say F stands for a function, functions in general. So it won't necessarily have a specific name. In programming, it always will. Here we see f of x. The x is an input value. X squared plus x is how we take that input value and transform it. Notice it doesn't say if x equals 2, then do something. It just says for any x, square it and then add that value to it, and the result will be that computation. Euler coined the term functions for this kind of transformation. In many programming languages, a block of code that would compute something like this, or something even far more complicated, is called a function, following Euler's terminology. In Java, functions don't stand alone. They're always inside a class. And when a function is inside a class, it is called a method. The distinction between a function and a method is function stands alone, the method is contained in a class. Java only allows methods.